Okay, good morning, everybody. And this is the final and fourth webinar of a series of 4 webinars organized by Deda Next within EDIAQI project, focused on making data about indoor air quality, but also ancillary data about pilot buildings interoperable each other in the different pilot areas. I'm Pier Giorgio Cipriano from Deda Next. I'm starting my introduction. This is the agenda for today. So I will very briefly recap what was the content of the previous 3 webinars, the main objectives of today, and then I will leave the floor to Dr. Giorgio Agugiaro from TU Delft that will introduce the OGC standard CityGML. Then we will have at more or less 10:30 and half an hour coffee break. And at 11, we will join back, in particular with EDIAQI partners, for a practical proposal on how to model pilot buildings and how to collect and share initial data. Okay, let's start. As already anticipated, today we have the opportunity to have with us Dr. Giorgio Agugiaro. He will introduce himself in a few minutes. As we know, this is the 4th appointment of a series of 4 webinars. We started in June with a general introduction to OGC standards and to the interoperability, to the need of making also our own data in a EDIAQI project fully interoperable. And then we jumped into SensorThings API standard, explaining what it is, which is the data model defined, how the APIs work. We had a look with my colleagues Beatrice and Luca and Martina of examples of SensorThings request. On June, we also started to present an open source solution, a server-side open source solution called Frost, that may be one of the reference implementations or to be considered also for a EDIAQI project. In July, we had a second session again on Frost. So we focused on practical information about Frost. We invited Dr. Hilke van der Schaaf from the Fraunhofer Institute, that is the organization working and leading the Frost open source project, and together with Martina and Beatrice, had practical examples of how to deploy on both Tomcat and Docker environment Frost open source solution. Together with Luca, we had a look also of how to ingest, how to feed Frost open source server with practical examples related to weather, traffic, and outdoor air quality in Ferrara. And last month, on September 29th, we introduced a parallel topic that is the visualization of dynamic data through JavaScript libraries, so through open source libraries for the web, but also with Python extensions. So with an extension of a open source GIS software called QGIS, with an implementation developed using Python to get the dynamic data from remote servers having a standard SensorThings endpoints. So all these materials, slides, and also the videos recorded are already available on the EDIAQI project website. So at the URL that you may have at the bottom of this slide, ediaqi.eu resources training sessions, you already have all the materials related to the first 3 webinars, and of course also slides and the video recorded today will be made available next week on the same URL. Okay. Before leaving the floor to Giorgio, why we are here talking about CityGML standard? Because as for dynamic data, also for data related to buildings, we don't want to reinvent, and we don't need to reinvent the wheel. There are laws, there are the European directives asking for harmonized data. In particular, this directive called INSPIRE that has a lot of practical technical guidelines, like this one that is focused on buildings, and this technical guideline is already linked to domains and topics like air pollution, also recalling other directives like the air quality directive. And from a more technical point of view, these guidelines are tightly coupled with the standard that we will introduce in a few minutes with Giorgio Agugiaro. Indeed, this technical specification that is required by the European directive INSPIRE is based on the OGC CityGML standard that was already partially introduced in previous calls and previous meetings, and as we will see in a while, is flexible and extensible enough also for the use cases foreseen in our project. So I leave the floor to Giorgio, to Dr. Giorgio Agugiaro. Giorgio, you can introduce yourself.
Yeah, I will share my screen.
I'm stopping the sharing of my screen. So to leave the floor to you.
So I think you should be seeing my full screen.
Yes.
First slide. Okay. Well, good morning, everybody. Yes, my name is Giorgio Agugiaro, and thanks for inviting me. Today, well, as already announced by Pier Giorgio, will give you, first of all, a gentle introduction to CityGML. Of course, we will just have a first look at what it is and what it represents. And then we will go a little bit further, but I will tell you during remaining time. A few words about myself. So I studied originally in Padova, which is an Italian city just a few kilometers north of Ferrara, if you know where Ferrara is. I did my PhD then in most of the time in Berlin, and then I started a little bit traveling around as a researcher. I was in Trento, also in Italy, then I landed in Vienna for a couple of years, and since 2018, I'm now a member of the Strategic Information Group in the Netherlands, in Delft. And I would say if I have to find a trade union of what I've been doing the last 10, 15 years is I'm focusing on semantic 3D city modeling for urban applications. And yeah, you will see in a few slides what we mean with semantic 3D city modeling. A few words also about my group. well, a group I'm a member of. The group is quite new. It was founded in 2015. We are physically embedded within the Faculty of the Built Environment and Architecture in Delft. The head of the group is Professor Giorgio Agugiaro. And well, here you can find the link to our homepage. By the way, all these PDF slides will be, of course, made available as PDF, so you don't need to copy any links. Here we just show you some of the partners we work with. So we are active at national and international level. And you already see here this OGC, which is one of the standardizations entities that, in our case, work or are particularly dedicated to spatial standards. Yeah, this is just a quick screenshot of the people who are in the group. And very briefly, if I had to summarize what we do, well, the idea is to design, to develop, and implement, I would say, better system to model digital twins of cities, buildings, and landscape. And of course, the overall purpose is to support environmental modeling and urban planning and design. Of course, we are embedded in the Faculty of Architecture and in the Department of Urbanism. So of course, there is a tight coupling with the topics and also with the user base, which are our urbanism colleagues. Okay, it's time to start. And I would say, let's start with a very few introductory slides. So we have on one hand a real city, and on the other hand, we want to represent it by means of what we call the digital geotwin, which means that we try to emphasize here the spatial or the geospatial dimension. Of course, it's not just about recreating the geometries. We need to, when we define a city model, ideally we should also include actors, processes, and not only the entities. And that's actually our ultimate goal. However, what we are faced with today, and I think this is also something which is going on in the next years, is that every community has its own language, and we have different communities according to different sectors. So, for example, talking about the energy community has its own community, its own models, indicators, and planning tools, but also the same applies to mobility, to ecology, economy, and so on, and surveying. And of course, everybody, as long as you work within the same community, everything is fine, everything is happy. And if you ask each one of these communities which digital twin is the best, of course, everybody will answer my digital twin, of course. The point is indeed, however, especially when we work at urban scale, that cities are some quite complex beings. And if you look at the heterogeneity of stakeholders and people actually exchange information within the city, well, we will end up like more or less it looks today, which is a quite complex and actually a quadratic complexity of relations that exist. And this is, of course, not very efficient because the probability of losing some information or not being up to date when it comes to the latest type of updates that are carried out is quite high. So, of course, the vision, and I'm not saying that we are already there, but the vision to which we are moving is to simplify and reduce the complexity from quadratic to linear. So we have just one connection of every stakeholders with a centralized system, and then we can call it common urban system model, where, of course, everything takes place and it acts as a sort of information hub. Now, of course, this is easy to say and less easy to achieve because it requires a number of layers of tools, repositories, processes, and services. So the pipeline needs to be developed in many layers. But this is exactly what the current trend is when we move toward urban digital twins. Now, this is, of course, just a simple graphical representation. And when we deal specifically with urban data, and I think this is a very well-known problem by everybody, we are faced with several data sets which are coming from different sources, and they have different reliability, they have different structures. And of course, every time integrating this data or making them somehow interoperable requires a lot of time and a lot of human resources. So of course, the trend is towards harmonized data. And the point is, instead of having each city adopt its own harmonized data information hub, following certain rules, there is a trend towards defining some standards. In our case, we look at standards for 3D city models, where, as Giorgio mentioned before, we don't have to reinvent the wheel, because behind every information hub, we also have to define APIs, software, and so on. So instead of having something which is city tailored, the idea is to generalize the approach and to make it available to multiple cities. Now, if we look at existing open geospatial standards, well, at least in Europe, we can see three main layers, and they are, I would say, in a somehow simplified way, you can map them at the scale they are active at. So Giorgio mentioned the Inspire directive, which is more at national level or actually international level, which takes care of forcing the states, the member states of the European Union, to prepare data in order to be interoperable and exchangeable at international level, mainly. And then in the lower end, where we are working more at the architectural scale, we have the BIM world, or actually the IFC world, which is the world of the building information model. And in between, we have the urban scale, where the most important open geospatial standard is basically CityGML. Now you will see also that there are some overlaps, and these are actually intentional, because this is where data from one world to the other can flow. Of course, there must be some work to translate data, because there are also different paradigms behind. We are going to see this in a second, but that's exactly the intention. Of course, generally, the data flow goes from the more detailed to the less detailed. So generally go from the BIM world down to CityGML and then down to Inspire. Although from a certain point of view, you can also go the other way around, but of course that's you are facing more and more the fact that you lack data, because you go from the less detailed to the more detailed. Now, exactly when we focus a little bit more in the geospatial standards, we see that there are two big families of standards. We are coming from the geospatial world, so we can say that we go down from the world scale to the building, but at the same time we have the architectural style scale, where we go from a single component up to the building, and that's where the two main standards a little bit overlap. That's exactly the building scale. And however, there are some big differences that make life a little bit more complex, or that are still represent some challenges where you have to exchange data. On one hand, we have CityGML. You can see CityGML as one example of the GIS-based approach. When you have, for example, here we see an example of a building modeled as a closed volume, and you see that you don't really have walls. The walls don't have a thickness. They are just represented by means of boundaries. On the other hand, you have IFC, where you have one building which is actually composed of many objects, and most of the times these objects are actually volumes. And this is also coming from the parametric modeling. So I would say some of the most common software used are Revit, or anyway some CAD based programs. Just to further visualize this difference, because this is a big modeling difference, at least in terms of geometries, you can see this. This is a pretty famous picture. You can see again on the left-hand side the GIS-based representation, where we focus on surfaces, and of course we can add semantics, so which means we can add further explanation of what is what. We can say that this is an exterior wall, this is an interior wall, and so on. And then on the other side, you can see the same object, which is represented, however, by means of IFC, which is the standard behind the building information model. And all entities are represented by means of solids. Okay, so going from one way to the other is most of the times possible. However, there are always some hiccups, and there is still work going on currently to allow for a seamless transformation of data from one source to the other. And sometimes some of the decisions to be taken are, especially when you go from the JS world to the constructive storage world, that there is no unique solution. So anyway, we are today focusing on the CityGML world, which means that we are starting as the closest entity at the building level, although you will see that we don't talk only about buildings. CityGML is an information model or 3D city models at urban and regional scale. As I mentioned before, it is embedded as it's now an OGC standard, and it's not focusing only on buildings. As a matter of fact, it covers all mostly relevant features or objects which can be found in the city. So we can also deal with traffic elements, terrain, tunnels, bridges, vegetation, and so on. On top of that, you can have that 3D geometry is used at multiple levels of detail, together with topology and semantics and appearance. Appearance is how you basically style your geometries to look like. Which means that here you have an example, a building, which itself is a concept, can have multiple geometrical representations. And here you can see the concept of LOD, which stands for level of detail, where a building, you can see that, you can imagine that building containing certain attributes, just like the construction, the number of levels, the number of stories, and so on, is the same, but it at the same time can be seen and can be represented up to 5 level of details, going from the classical 2D footprint to an extruded shape, which is level 1, and then more and more to more detailed representations. One last thing is that CityGML can be extended by means of so-called application domain extensions. We are not going to cover this today because this would require way more than 1 hour and a half. But Giorgio has been actively involved in some of the AD development, specifically for energy in the past years. We met there, and so he's also a person you can refer to for further information. Now, briefly, CityGML was originally released in 2008 as an OGC standard, CityGML 1, followed 4 years later by CityGML 2, which is basically just a minor update to the standard, with the biggest difference being the addition of the bridge and tunnel modules. And this is also the core of the presentation of today. In the meanwhile, however, there has been the latest version, which is CityGML 3, which has been released in terms of data model in 2021. And it consists of a major revision of the existing modules, although the modules of CityGML 2 are still there. We're going to see this in a second. And there have been more additions in terms of versioning, dynamizers, and support for point clouds. Again, no worries. I will give you a brief overview of the news of CityGML 3 at the end of this presentation. The reason why we focus on CityGML 2 is that it is still de facto the current version, which is mostly used, adopted, and software is still being developed for CityGML 3 from the data model, and which means that the adoption is starting, but at the moment, the most frequent use is still version number 2. Now, graphically, how can you imagine CityGML? So CityGML uses the grammar of GML, which stands for Geographic Markup Language, and it builds upon CityGML core, which contains the main functions, actually the main classes, and then you have specific modules. You can see them pointer. We can see here the core modules, which cover most of the relevant objects in a city, as I mentioned, the relief, water body, vegetation, land use, and so on and so on. However, you can also have the possibility to extend the data model depending on specific application domains that you make. Here, I mentioned with energy, there is also a utility network, ADE, and so on. And these are developed independently, but can be integrated to extend CityGML depending on the needs. Now, if we focus at the building module, we'll have a quick look at all of these modules just to have you an idea that it's not just buildings. We can say that actually nowadays, from the GIS community, generation of city models up to LOD2, which is this kind of level of detail, is nearly completely automatic. And geometries can be modeled as solids, multi-surfaces, or thematic surfaces. What does this mean? That from LOD2, we can also distinguish what is what. So here, this is just a simple geometry, but here we can really decompose this geometry and be able to distinguish between the roof surfaces, the wall surfaces, the ground surfaces, because each one maybe has different properties. And this is, for example, the case with the energy modeling, where they may have different thermal properties, or they might be associated with different values from heterogeneous physical properties. The LOD3 and LOD4 currently are not yet widely used. They are coming then as import or as transformation and translation from generally BIM, as building information modeling models, because they are way more detailed. However, if you look at the size of a city, very often BIM models, depending on the country, are just a few percent available. So nowadays, I would say the standard for having a city coverage is LOD1 or LOD2, with some buildings in LOD3 and very few buildings in LOD4. What is more, still, we can, looking at this building model, we can split it into building parts. The concept of building part is that a building might be composed of different parts. The definition can be done based on functionality, or, for example, on characteristic different shapes. But this is up to the user to choose whether or not to subdivide the building in building parts or to keep it as a whole. This is one of the possibilities given by CityGML. And as I mentioned, it's not just about buildings. Now, I'm just going quickly through the other modules, but to give you the overview that the same logic applies many, many times. If we look at the tunnel module, from a geometrical point of view, we can again see that there is a multi-LOD representation. So we go from LOD1 to LOD4. And again, you can represent the exterior, depending on the available data, and then as well the interior, again, depending on whether you have data or not. It's not prescribing that you must model it in LOD4, but it gives you the possibility to have a slot to fill this geometry representation if you have it. Now, this is the tunnel module, but the same goes for the bridges. Again, same approach. You can model it according to the geometries of the exterior in different LODs, and the same goes for the interior. If we talk about city furniture, this is also, there is one characteristic here, but the idea is the same. Additionally, when we are talking about standardized objects, so objects that are actually produced many times, you can use the concept of implicit geometry. So you can basically store, or you can model your object only once, and then you can place it around and clone it many different times in the city. Think, for example, of street lamps or traffic lights or bus stops. So you don't really need to represent it by means every time of a specific instance of this object, but you can really say, okay, they are really industrially produced. I just need one model, and then I clone it and I place it in everywhere of the city where it is actually to be found. Vegetation, you have two possibilities. You can really model each vegetation at a single It's called solitary vegetation object. So you can, the best example is that you see every single tree modeled as a single tree. And the same applies here in terms of different LODs. But you can also think of aggregated areas. It could be, for example, a forest where you don't really need to model every single tree. You can just represent it as a solid or a multi-solid, or even just as a 2D, but 2.5D representation, which is a plant cover. Okay, so you just represent an aggregated area which is going to contain some vegetation by means of a simplified geometry. I'm focusing here on the geometrical aspect. I will briefly mention later that, of course, each one of these city objects, each one of these objects that we are representing are also provided with a set of standardized attributes and relations so that you can define what is what and what certain characteristics are. For example, in terms of the building, it could be the year of construction, the number of stories. In the case of the tree, it could be the year, so the species, the size of the trunk, the size of the crown, and so on and so on. Now, quickly again, the transportation module takes care of representing everything which is related to traffic areas. So you can again decompose it according to the different functions, like the pedestrian zone, the parking lots, and so on and so on. They are generally called auxiliary traffic areas. And again, you can see here different level of details associated with the concept of transportation. And as I always like to repeat, it's not obligatory to model it in all LODs. We just choose the most suitable one or the one we have data. Another module regarding land use. And again, I'm not going to spend much time here because this is a little bit going beyond the building size you are focusing on, but this is just as a more of a general idea of what you can model. The same goes for water bodies modules, where you can represent your water bodies in different levels of detail, but also with different level of semantic representation, either considering the water body as itself or even going down to splitting the water surface, the water ground, and so on and so on. Last but not least, we have the terrain module, which is used, of course, to represent the terrain. And here you can have also different representations. One is the classical raster-based one, but you can also have the vector-based one by means of a triangular network. And what you use is also depending on, again, the available data and your application. I will only briefly mention here 2 or 3 other modules. One is the city object group, which allows for arbitrary grouping of city objects. For whatever reason you may want to group for a certain study, certain city object, then you can just define the group. We have a generic module, which allows to either define new city objects which are not already in the standard. So imagine you need to define, I'm just making an example, it could be a car, or well, something which is actually not moving, is mostly a static object, but which is not already predefined it could be, in the standard, or that's what is also most commonly used for. You can also define generic attributes, which is adding attributes which are not already defined. Generally, I think, imagine you want to store the architect of a building. This attribute is not standardized, but you can add it, and you don't have to change anything in the standard. This is one of the ways to extend CityGML. Last but not least, again, the appearance is basically a module that allows you to define how features are represented by means of defining, I would say, colors or by texturing them. But we're not going here into the detail. That's a little bit beyond the scope of today's presentation. I would like to just conclude this very, very, very quick superficial introduction to CityGML, stressing out probably the main concept behind this kind of semantic modeling. 3D visualization is what we always are facing. So what we look at, and is, however, just the tip of the iceberg. It's easy to see, it's easy to realize. However, the very complex things, but also the added value is what attributes are associated to these geometries, what relations exist between a building and the neighboring buildings, or between the building and the vegetation around. So this is what, of course, costs more to produce, but also yields to smarter application being built on top of that. However, this is not visible, and that's why there is sometimes a little bit of confusion when talking about 3D modeling or 3D city modeling, and we prefer the word semantic 3D city modeling because this is this concept of enriching geometries by additional information to help us and the computer distinguish between just geometries. I just have 2 more slides that go a little bit more into detail. But this is needed to avoid some misunderstandings. So CityGML is actually 2 things. It refers to the name of the data model, which is the conceptual model, and it's mostly it consists of UML diagrams. I have an example in the next slides. And then it also refers to one of the possible encodings of the data model. And the encoding is how the information defined in the conceptual data model is actually read, for example, to a file. Now, there are, in terms of files, the most common encoding is by means of XML. However, for example, here at Delft, we have developed a second encoding, which is called CityJSON, which is consisting in writing the same type of information in a JSON file instead of an XML file. However, there is also a third encoding, which is based on SQL, and it's called 3D City Database. And I'm going to give you about this third one a little bit more details in the second part of the talk. Now, what is important is that we have on one hand the document containing the data, in our case, for example, in XML, but we also have the rules and which are corresponding to the data model rules, which are encoded in an XSD file, which is called XML schema definition. Now, a normal user doesn't need to know all of this, but why is it relevant? Because software can use the XSD file to perform a validation of the contents contained in an XML file, which means that the computer takes care of checking automatically whether the document that you are receiving is written correctly. And this is not, of course, this is not something you want to do manually, and that's why this is now carried out. Well, now, this is actually, it's been around for a while, but this kind of validation is taken care of by the computer, but it needs to know how to perform, how to check these rules. And these rules, for example, are encoded in an XSD file. I'm stopping here with the details. It's just to avoid, however, some naming misunderstandings, because as I mentioned here, CityGML is on one hand the conceptual data model, and it consists of UML diagrams and the written specifications. It's a document of PDF of 300-400 pages. And then you have the encodings, which is basically the way you write the same type of information according to the platform or the software you're using. And again, you have the CityGML, which actually I prefer to call now XML-based CityGML. And then you have JSON encoding, which is JSON, and then you have the 3D City database. A concrete example of how it looks like, you have the data model here, which is modeled in UML. And here you can, well, probably hard to see, but you should see some attributes. And then on top of that, you see all the relations to geometry. Now, this is mostly hidden to the user, okay? But if you're, of course, delving into the details, this is something that you need people who can read and work with this. But on the other hand, the files or the encodings, this is an example of an XML encoding. This is how a CityGML file looks like. It's basically a text file encoded here as XML or as a JSON. I don't have a screenshot, or you will see later as SQL by means of tables. So this was just a quick introduction, and I just would like to show you some applications where CityGML is used. Here you have some examples where semantic helicity models are used to, for example, perform explosion simulation. This is an example from Germany where they need to know how many people and what is the risk of evacuation or for the buildings if, for example, a bomb from World War II is found during the renovation of a building, and they need to know what is the affected area. This is flood risk analysis, or this is, I think, yeah, this is Zurich, so it's cellular, radio planning pollution, urban planning, and so on. This is also another example of possible applications which go from noise, emission mapping, disaster management, well, simulation, of course, navigation with augmented reality, and another of course, architecture and urban planning is one of the major application fields where this is used. However, and this is just here, I just put some links that you can refer to later. There are also a number of other applications. One is, for example, energy, and here an example of the estimation of solar irradiation on all surfaces, considering also the mutual shadowing of the surrounding buildings. And one example is to evaluate the suitability for solar panels, but photovoltaic or thermal. Another example regarding traffic simulation, and this is, I think, in Munich. And here you have an example of planning street lighting. So, of course, since you're playing with a, let's say, digital toy, then you can perform different scenarios and evaluate the different scenarios using the same digital environment. Of course, CityGML, well, digital twins should not cover only this overground, but also the above ground, but also the underground. This is some work, for example, I did in the past years regarding supply networks. So how the city is connected, what actually feeds the city in terms of energy, in terms of water, in terms of information. And I think you will agree that this is still a problem whenever you dig somewhere in a street. There is always the issue of knowing if you're going to hit some existing utilities or not. Another example regarding urban noise. This is the work done by my colleagues here in Delft, where we use the city models to perform noise simulations and to see how they impact the existing building stock. Another example, again, back to energy. This is actually a previous work I did when I was in Vienna, but this is also some of the work that allowed us to develop, for example, this energy application domain extension, where we work together with Giorgio. And it allows us to estimate at single building level the energy demand of or the energy performance of the building, and to evaluate where the most inefficient buildings are. Of course, since we're working at the granularity of the building, we can go up and perform them spatial applications if it is required. And again, as mentioned before, since we are playing with a digital toy, we can also say, okay, this is the status quo, this is how it is today, but we could also perform some different scenarios of refurbishment and evaluate, for example, if it's feasible, if it's how much it costs, and so on and so on. Another example when it comes to microclimate simulations, here the idea is not to reinvent the wheel. There are already existing tools that take care of simulating microclimate. The point is that creating the 3D models that they require, here you see it's a voxelized model because this specific software requires a voxelized model, but a lot of time is spent by the, for example, microclimate modelers in creating these 3D models. And the idea is, okay, instead of spending time to recreate manually the model, let's import it and export it from an existing 3D model. And of course, we need to perform some conversions in the middle, but basically the urban scene is then already available. We run the simulation, And then we take the results and store them back into the 3D city model. And this is a very important concept because what the output of a specific discipline is could become the input for the follow-up study. Finally, this is also work from a colleague of mine here at Delft. She's focusing, ironically, not really on the buildings, but on the voids. Actually, the building play a role, of course, in terms of CFD simulation and how, for example, pollutants dispersion happens in the city considering the urban fabric. Another small example regarding urban planning, where some of my colleagues, but this is a work I did 2 years ago, we used the electricity model of today to extract some KPIs and feed them to the urban designer in order to support the design of new districts. At the same time, to reduce the number of scenarios that a designer needs to come up with. So we can then evaluate the impact of the new scenario in the current city. This is, of course, more urban planning related. And then this is another example where computer assisted, this is a little bit of AI or machine learning based. This is assisting the urban designer in identifying where densification would take place. So providing some hints at the shape and the location of, let's say, free spots or free plots where it might be possible to densify a city. That's especially in the Netherlands, a very hot topic these days. I conclude here a quick overview on the applications. I just show you some of them for the sake of time, but the idea is exactly that 3D city models can play a major role in supporting and feeding information to a number of related applications. And again, the idea is not to reinvent the wheel or to let people from the different disciplines spend a lot of time in recreating the urban scenes that they need, but to provide data and, of course, get back the results. That's one of the additional values. The last part of the slides is dedicated to a quick overview of what CityGML3 brings. Again, I'm not going very much into the details because this would require a bit more time, but I will focus only on the major views. So as I mentioned, CityGML3 was published, the data model was published in 2021, at the end of 2021, I think it was September, basically after 9 years of development. I would say the major innovations is that there is a new conceptual data model, again, defined by UML classes, which is, however, completely separated by it's better separated for the encoding. Some modules have been revised. May I ask you to mute yourself? There is some noise in the background. Giorgio, could you please check? Okay, and there is a new space and a new LOD concept. I will talk about this in a second. And also, although we are not going to cover this, is a slightly simplified way to define these application domain extensions, so the way you extend CityGML. Visually, okay, it's just flipped top to bottom instead of bottom to top. You see that there is a CityGML core, and then there are some common modules. You see here the dynamizer, the versioning, the point cloud. I will briefly mention the dynamizer, which is new, and then more or less all the others are still there. You have the water body, the vegetation, transportation, and so on, the tunnel, bridge, and buildings. Okay, there is a new layer in between, which is just facilitating the conversion of data between the building information model and CityGML world, but mostly the overall structure is still the same with some additions. Let's have a look. This is, however, so one of the major differences that the core has been structured in a way that it has, on one hand, it has been added with new concept. Sorry, But there has also been a little bit of redesign in order to simplify the single modules here and to bring back some of the common properties to CityGML, so to the core, so that basically everything is needed by all modules is in the CityGML core. This is more of a design strategy. I will not stop much more here. But you can see that there has been, this is the core module from CityGML 2, where you have all the modules then connecting, city furniture, building, and so on. And this is the new module, which seems a little bit more complex. Okay, there has been a little bit of shifting things all around. And again, the purpose is not that you are able to read this here. I just want to highlight that there are a couple of new things, which are, for example, the dynamizer. And again, I'm mentioning this in a few slides. It's the possibility to link to sensors, for example, point clouds. That's probably for you of less interest. Geometries and the space concept, which I'm going to, however, to briefly mention because this is completely new and is meant also to simplify interoperability with the BIM world. Now, again, don't be scared about this. This is just an overview to see that there are some additions. Now, probably one of the largest new concepts that have been added to CityGML is mostly a conceptual concept regarding space, which consists in a subdivision of and the classification of objects according to the space they use. So the first thing is to consider an object either as a volumetric object, here you can see the building as itself, or as the boundaries that define this object. The second part is to conceptually define whether you have a physical space, could be a room, okay, or a logical space, which means you can consider parts of the building in arbitrary order, for example, according to function. You could define stories, you could define flats, you could define specific areas of the building. I'm talking, of course, of the building, but the same applies to all other modules. And the last part is to define whether an object is, whether a space is occupied. For example, case here you have an example of a furniture piece, or in saying on the street, a street sign, or it is unoccupied space. And these are volumetric physical objects that do not block space for other things. We can see this as a possibility to model also the so-called voids. And think, for example, if you want to model within a building or within a room, the distribution of temperature or distribution of humidity or whatever. Of course, you need to be able to associate to something which is a void, a series of attributes. And this is it's now possible thanks to this specific concept. Another change is it has been the level of details have been simplified. So you can see there is no more LOD4. However, there is a decoupling of the interior from the exterior, which means that you can model the exterior according to the available data, again from LOD0 to LOD3, depending on what you want or what you have. And the interior can also follow different LODs. They are not tied anymore to LOD4. And this is also to allow and to be in line with available data. You can imagine that these could be information coming from the raster. And here you may have some simplified group representation, especially in those buildings where you don't have a high level of detail coming from, for example, from Revit or from an AutoCAD model, and you just need to represent it parametrically in a simplified way. A few words about the dynamizer, and I'm nearly done with the first part of this presentation. The dynamizer is a new addition. It basically enables to represent time-varying attribute values. And again, the best example is temperature throughout the day, a month, a year. It also provides classes to integrate sensor data with 3D models. So basically, you can associate to every object in the urban context, which is either a building, a room, a table, or a traffic light, or whatever, as many sensors as you want. And because basically a dynamizer is itself an object that injects time-dependent data to an individual attribute of city object. So you can really change whatever. It could be the number of residents or the number of people within a building, which is itself a value that changes over time. You can represent it as a static value, but you can also represent it by means of a time-dependent value. I would like to conclude here. Okay, yes, it's 10. Well, that 3D city models can be a very powerful tool, of course, but it depends on, of course, well, first of all, there are still some challenges, technical, conceptual, that making working with them not always straightforward. Let it alone the fact that, of course, very often you need support from the experts because, yeah, it's not really like working with a text file. So you need a little bit of background knowledge to understand the complexity behind it. Still, they are gaining more and more momentum. They are becoming nearly ubiquitous. So it's something that you should consider before starting a new project. Of course, it depends on what you want to do, which data, which tools you need. It's also very good to know whether there is already a 3D city model in your study area or if you can generate one quickly. And of course, the very fundamental question is a 3D city model going to help you for your application or not? And if the answer is no, of course, then you can skip all the everything which is required and goes beyond it. But in case of that, I would say always ask the experts because maybe you may be missing out some aspects that you are not aware of. So I would like to conclude this first set of conclusions with saying that, of course, semantic 3D city models will not solve all the problems. And of course, I shouldn't say that because that's exactly my work, that's the reality. However, chances are high that you may profit from them, especially when you're working at the urban scale, starting from the granularity of a building. Now, after these first 15 minutes, if you feel lost or overwhelmed, well, don't worry, it's absolutely normal. You've been loaded with quite a big amount of information, okay? On top of that, CityGML is extremely vast and fascinating work, but yeah, I'm Italian. I like to talk about food, so I can say that it's a dish that takes long to be appreciated, of course, also digested, and surely longer than these few slides that I showed you today. Nevertheless, one of the advantages of CityGML is that we don't really need to focus on all, let's say, ingredients of this recipe. I'm referring here to the modules at this point. So you don't need to focus on and learn them and understand them all at the same time. You can just focus on those that you need for your specific application and then leave the rest to another time. I conclude here the first part of the presentation. Are there any questions, first of all, before I move on to the second part?
Okay, let's see if someone is anyone that wants to break the ice. Otherwise,
or still alive.
Yeah, I have some questions for you Giorgio, but I will leave my questions for
later.
After your presentation, so before the coffee break.
Okay. Okay, I see nobody raising the hands, or I do not the chat. No, even the chat. Good. Then I would say hold the breath. The second part is going to be definitely easier. I'm just going to show some quickly an overview of some software existing software to work with CityGML. And then I will focus on the database side and give you a quick overview of what you can do also in terms of to manage and to work with data, CityGML data stored in a database. Okay, I need to stop this presentation. That's the other one. And I think I should make it in no, sorry, wrong. You should see my new presentation. Can you confirm, please?
Yes. Yeah.
Oh, okay.
Yeah.
Okay. This is just a very quick overview. I will leave it, so I'm not going to talk in detail about each piece of software, but it's more of a reference for you later to have a look at if you want, if you're interested. There are a big family of tools that are available to work with CityGML. And again, here I refer to CityGML in general terms. Of course, keep in mind there are three main encodings, two file-based, which is the XML-based and the JSON-based one, and the third one is the database one. But still, if we look at it as a whole, there are different operations that you can do, going from data modeling to viewers, to look at the data, to generate, so to write CityGML or CityJSON, to parse data if you are more on the programmatic side. Of course, there are, of course, validate databases and so on. So I will just go quickly. Of course, the first step is if you need to extend CityGML, for example, to perform, to do some data modeling. And here, basically widely used software is a commercial one, which is Enterprise Architect. And once you have the UML of your, for example, extension, it goes through an open source tool, which is called ShapeChange, which automatically generates the XSD file from the UML diagram. And you remember the XSD file is the computer readable file containing the rules which are then important for validation. If we go to viewers, well, one of the available viewers for XML-based CityGML is the FCK viewer. It's freeware, however, it's only for Windows, and it visualizes XML-based CityGML and IFC. So you can actually visualize at the same time CityGML data and, oh, sorry, in the same tool, CityGML data and, for example, BIM models. And it also opens and visualizes ADE datasets, so extended datasets, although again, for the purpose of today, this is now not relevant. And again, I put here the link, so if you're interested, you can click on it and find further resources. For the map world, there is Azul. This is developed by a colleague of mine, and again, it's a visualizator, so you can on one hand explore geometries and on the other hand explore the attributes. So you cannot edit, but you can still visualize in 3D. One of the most used softwares to also visualize CityGML, be it CityJSON or XML, whatever, is FME. It's a proprietary software by Safe Software. It's commercial. However, it's quite powerful. It's also multi-platform, and you can, again, visualize CityGML and so on in a number of formats. Last one is a plugin for QGIS. Well, there are more plugins, but one of them is the CityJSON Loader. It's, again, open source, and it was developed by a former PhD of ours here at Delft. It's, again, available as a plugin for QGIS. And it allows you to load the CityJSON file and to visualize it in QGIS. Again, these are visualization tools, so you are not allowed to do any edits. Now, if we want to generate CityGML and you don't have an already existing data model, city model, well, one tool, open source, which is very popular, is 3DFire. This is also developed by our, well, it has been developed by our group. It's open source and multi-platform, and it not only generates CityGML, but also CityJSON and other formats. The basic idea is that you have the footprints, the 2D footprints, a classified point cloud, and now I'm oversimplifying, you press the button and you obtain automatically LOD1 city model, where you basically have the buildings raised or extruded to the average height of the roof. It has been, however, improved. Now we have a spin-off, which is called EDIAQI. For former colleagues have been worked on that, and now they have founded a spin-off, which have brought forth the concept of electrifier. Now it's called GeoFlow, actually, and it's allowing you to model a building in LOD2, following the same principle. You need a footprint, you need a classified point cloud, and what you extract is, however, an LOD2 building where the roof surfaces are represented. It's open source, works on Linux, and again, you see it generates a number of different formats. And here you can find further links if you're interested. From a commercial side, there is also, for example, City Editor. I checked it no more than 3 days ago. It's still there. It's further developed. It's developed by this company, German company, 3DIS, and it's commercial and Windows only, but in SketchUp, you can then perform some edits and create some CityGML related files. And again, as a matter of fact, you can even, starting from a shapefile, starting from CSV files, starting from whatever, you can use FME Workbench. This is, again, in the GIS community, one of the most commonly used ETL, so extract, load, and transform tools, because it gives you a set of readers. Basically, you can read up to, I think, 400 different types of formats, and including CityGML. And you can also, then in the middle, you do your transformations, and then you can write CityGML files or CityJSON files. And in between, well, it's up to you. It's basically a visual scripting language. It's commercial, as I mentioned before, and it also supports ADAs. Parsers, this is more if you are into coding. Then there are two main parsers, which is CityGML for Java, which is again open source Java-based library, which allows you to read and process and write CityGML datasets, both XML and CityJSON. And again, here the link. And then you have CityJSON.io, which is Python-based, and it reads, processes, and writes CityJSON datasets. And this is also developed by our group and supports CityJSON. Basically, they have similar functionalities. One focuses more on XML, and the other one focuses more on JSON. But there are, of course, other parsers and APIs for programmers. We have just some links, or well, not links, sorry, some keywords. You can look them up if you're interested, or again, you can refer to Giorgio, or you can drop a mail. I can answer. We go to the database. So the reference implementation for the database is called 3D City Database. It's a geodatabase schema which allows you to store, to represent, and manage basically CityGML data on top of a standard spatial relational database, which could be either Postgres, PostGIS, or Oracle. It's not just the database, so basically the tables and the functions and whatever has to be stored in terms of database schema, but it comes also with a very powerful Java-based importer-exporter, which is also provided with a graphical user interface. And with this importer-exporter, together with the database schema, you can basically just click the button and connect to the database and import CityGML or CityJSON files, export, again, data as CityGML or CityJSON, but on top of that, also export to GeoTIFF or KML Collada files and so on, basically to a number of other formats. It's open source and open platform, and again, you can download it and check the further documentation in the links that I leave. There is another NoSQL database, which is called GeoRocket. Personally, I have not worked with it, so I don't have direct experience, but it's focusing mostly on NoSQL technology behind it, and it's mostly related if you need to serve chunks of so to serve CityGML data, well, not only CityGML data, but also GML data in a quick way. And yeah, the best thing is if you're interested to focus on, to have a look at the link that I made here. Web-based visualization, just an overview. Well, Google Earth Pro, I think I don't need to introduce it, because everybody knows it. One very useful thing is that it can visualize CityGML data exported as KML or things data using, for example, the importer-exporter that I mentioned before. So this is also a very practical tool to quickly check if the geometries, what you see here, attributes. This is a former city model that I created when I was working in Trento. You can check the attributes, and this is a very quick way to also consume the data and have a look at it. Of course, more and more powerful, or more and more Cesium is being used, which is a JavaScript library, which is used to create 3D globes on the web browser. It does not have any plugin dependency, and I assume that most of you should have heard of it. Otherwise, again, you can check the link that I provided. And yeah, this was meant to be very fast, because now we're going to have a look at CityGML, and again, it's mostly a few slides. Just a minute. Okay, you should see now my new presentation.
Yes.
Okay. Yep. You have to move some windows around. Okay. What is the traditional database? I mentioned it already before. It's on one hand, well, it's an open source implementation of the traditional of the CityGML data model. Now, in very simple terms, well, it is for Postgres or for Oracle Spatial, and it consists of well, 66 tables, put in very simple terms. Predefined tables and several functions that are installed into a database instance. And then it comes with an importer-exporter, which, as I mentioned before, which imports XML and JSON data, exports it, but also a number of other formats, as I mentioned before, for example, for visualization in Google Earth or in Cesium. I will give you a quick overview of some of these functionalities. I just have screenshots to make it quick, but I also add here a lot of links for further resources if you want to download the software, test the software, or just read about the documentation and are curious about more details. So first of all, the homepage is where you start from, and then there are links to, for example, GitHub to download further resources. This is exactly the GitHub homepage, and yeah, there basically you can download the different things. The main idea is exactly this. We have talked today about the data model, the conceptual data model, which is represented by UML class diagrams. But then you need basically to transform it into tables. And this well, mapping has been already carried out by the colleagues who did the 3D database. And on top of that, of course, you need an importer-exporter that reads CityGML data and transforms it and loads it into tables. And then again, this is just an example. You can also export it to KML. This is just a simple screenshot of the GUI, of the graphical user interface. It's quite simple. You just have basically some tabs which allow you to import, export. And here, this is an example where you can take a portion of your city model and export it. In our case here, this is to KML. And what you get is basically a file that you can visualize in Google Earth, just really by dragging and dropping the KML file into, in this case, into Google Earth. And of course, it's not just, you can choose different geometries. You can export according to LOD0, LOD1, LOD2, and so on and so on. And as I mentioned before, you can also quickly export the associated attributes so that you can quickly check them. Again, this is of course just visualization, so you cannot edit data. You cannot go back to the database and perform edits, at least using PML. Another thing you can do is you can export attributes, just simple CSV files. So if you need to do some analysis for whatever reason in Excel or whatever, that's just a simple interface that allows you to export a very simple CSV file. Again, it always depends on what you need to do with the data and if you need to do that. I will just spend maybe 2 or 3 slides because I need this for the last part of my presentation on how this mapping was carried out. So you know that, well, again, the point is to go from this conceptual model to an entity relationship model, which is what we need in a relational database. And the process is a little bit complex. I'm not going into the details. So of course, you see that a number of tables have been created which correspond to different classes. Now, the core of what I want to say is that dealing with the 3D CTV is extremely powerful, but this comes also at the cost of a certain complexity. For example, I'm just making an example of a building. Everything which is related to a building will end up being stored in different tables, and these tables are linked. So if you are working on a database, you are an SQL expert, you will have to link tables and write queries which are a little bit more complex than just retrieving data from a simple table. This is an example of the building. You can see here the primary key. So these are just 2 tables. Everything is a city object, and then you connect and you have further attributes stored in the table building. Here you have, for example, the name, the number, the year construction, the type of the roof, and so on and so on. The stories about ground, and here you have some generic attributes. On top of that, if you want to store geometry, you need a 3rd table, which is called surface geometry. And again, don't worry, I'm just doing this as a teaser for the next and last part of the presentation, where you have to store the geometry. Here you have a foreign key, which is actually referencing the solid, the geometry, which is then further split, for example, into polygons. So this is a rather complex structure. If you just import and export, you don't need to do anything because everything is, of course, working out of the box. The point is, however, if you want to perform some updates and you want to work directly on the CityDB, of course, you need good knowledge of the structure of this database, which might require some time. To close, and again, I promise it would be quick, and then we're going to the sweet side of the 3D database. The 3D is not just tables. There are also a number of functions that facilitate data maintenance. For example, there are a number of delete functions that are already predefined that help you if you want to delete a building. You don't really have to go through all tables. You just delete using the ID of the building, and then it's cleaned up automatically in all associated tables. It is also possible to have multiple CityDB schemas, so you can see these as sort of storing multiple scenarios of the same city model in the same database instance. And again, this is supported also by the graphical user interface. You can see here further details if you're interested. And again, the current version adds some preliminary support or extensions. So it is possible to automatically generate the new tables that are needed if you define a need. I stop this quick introduction about the 3D CTV here, and I have the last 9 minutes perfect to introduce the last part, which is actually partially going to give an answer to this complexity. Okay. Good. So I assume you can see.
Yes.
Okay.
Yes. Yes.
Good. These are the last slides, and I think, yes, I should make it in time. And I hope this to be really quick then, otherwise we may. So, sorry. The point is, now, in order to cope a bit with the complexity of the 3D CTV, from the user perspective, we have developed here at Delft a plugin for QGIS, which basically, tries to cope with some of the issues, some of the less easy to face characteristics of 3D CTV. For example, what is the idea behind it? So, semantic 3D models are becoming quite common, and generally this is an example of the whole Netherlands, which is currently available as one unique city model. However, of course, generally huge data sets are split into file-based portion, for example, tiles. Now, if you see, of course, you can have smaller data sets, but in the case of the whole Netherlands, you are working with over 8,000 files. Now, of course, the next natural step is to store everything into a spatial database. And again, that's where the 3D CTV comes into play. And the idea would be, why not letting users benefit from directly working with the 3D CTV? So you can skip working with files. However, I mentioned it quickly earlier on, editing features, attributes should become easier. So it should reduce the amount of SQL that you need to write. But at least we are aware that SQL is quite well known also outside the GIS community. I mean, of course, it is well known, at least at some basic level, and at least when it comes to spatial databases. However, the CityGML data model does not follow the simple feature for SQL models. So we don't have basically shape files where you have one geometry and all attributes. I remember here the concept that you have one object, which is a building, but it can have multiple representations, and this makes life a little bit harder. You have nested features, so you have, for example, that a room is part of a building and so on. And then you can see a representation as a combination of the LUD, the geometry types, semantics, and so on. So we did a tiny little bit of exercise of all possible representations that you can come up with in CityGML. And of course, this is just an extreme case. You can come up with 607 plus possible representations. This is never going to be the case in the real data set because you have way less, but you need to cope with this kind of possible heterogeneity, and in the database, you also need to tackle this. So the idea is, why not using QGIS? That's where our plugin comes in. The idea is to create or to give the user the idea that it's basically using a sort of classic GIS layer. And these kind of layers hide the 3D CTV complexity. They automatically deal with different geometries, multiple LODs, whatever. You just choose, and the magic, let's say the magic, is taken care of in the background. And of course, that's most importantly, that most of the attributes, I showed you the example before on purpose, that are split over different tables, should be merged into what we call a single table. It's of course not really a table, but it doesn't matter. The idea is one single object. Second, we need to deal with the fact that city models can become quite big. So we will never be able to load, for example, the whole Tokyo in QGIS. We need to put up some checks in between to reduce or to warn the user that there are certain sizes that are allowed, and beyond that, so those sizes, the system may crash. And then we want to be able to edit attributes, of course, depending on the user privileges. At the moment, we don't allow any editing of the geometries. That's by design, but we allow to delete features. And of course, but this is really database stuff, we support multiple types of users with different privileges, so you can be either read-only or read-only. Now, very briefly, the QGIS is composed of two parts. One is on the server side, which is installed on top of the database, and then the rest is just a Python-based plugin which works within QGIS. For the sake of, so there are three tools at the moment. One is called Layer Loader. Well, you can imagine what it does. Basically, it creates layers and loads them into QGIS. a bulk deleter, which allows you to delete features, and EDIAQI package administrator, which basically allows database administrators to install the software and so on and so on. For the sake of time, I will just quickly give you a live demo. And so I take here, wait a minute, I need to remove JS here. So what you do is you basically connect to the database. Okay, of course, I've already prepared a little bit. So we connect. And you are immediately presented with different schemas that you may, different city models that you may have in the same database. Then, well, what you have to do, I already did it, sorry. You basically decide to create the layers. You populate them. That's it. And you then can basically select what kind of feature you want to import. Let's say we want buildings and LOD 2. You are presented with those layers that are available. For example, we have the LOD 2 buildings, but we can also have the thematic representations, and then you import them. So wait a minute. And at the same time, you can also say, okay, I want, for example, to import the trees in LOD 3. Then you are presented with those layers that are available, so only layers for existing data, not all of the 607 possible combinations. You import them, and here you go. Now, that's it. We are inside QGIS. We can do everything we generally do in QGIS. So you can, of course, explore buildings within attributes. Oh, sorry, it's opening in the other window. So we have prepared here, for example, customized attribute tables, attribute forms, where you basically have access to all different attributes of a building. Here, for example, you have different links and so on and so on. I'm showing you now notification. On top of that, if you are granted sufficient privileges, you can start editing the values. And so we can, for example, change and save. And on top of that, we are also adding some checks to include data quality, so that you are not allowed to enter data which are not compliant with the data model. Now, of course, once you store results directly back to the database. So in this case, you can re-edit the attributes and store the results on the source data if you are allowed to. And yeah, last but not least, but of course, now we can start a new one. Since we're working on QGIS, just a minute, we need to get the window here. We can go back, we can change the city. So here, this is an example of a quite huge data set that you can reduce the size of, depending on the area you want to work. So you can even speed up the generation of the layers. Here, I've already done it in advance for you. And you are shown the area. Again, we can example here. Or you can also load another LOD. Let's load LOD 1, for example, and LOD 2. And it's adding up. Now, let's see if it works. This is one of the weak spots of QGIS itself, but we can go into 3D visualization. And it's opening in a window, sorry. And again, we have our buildings in 3D. This is, by the way, not our work. This is just another plugin from QGIS. But yeah, as you can see, you can consume CityGML data storing to this DBV directly from VJS. And I just showed you, of course, the buildings, but the same goes for DTM, for for bridges, whatever, everything that you can visualize. Okay, I'm going to go back to the presentation, and I'm nearly done. Yes, I need 3 more minutes. I hope this is fine. We did some tests with cities of different sizes, and so far it works quite well. We didn't get too many complaints or issues from the users. One thing is that due to its dual structure, so we have a server side and a client side, you can even completely forget the client side in QGIS, and you can access directly the server side only, which we call QGIS package. This is an example of connecting to the layers as I did before. Do whatever you want, for example, in FME, and then basically update the values, everything being carried out in FME. So here you have interfaces to the small API that we have built on top of it, which we call exactly, as I mentioned before, the QGIS packaging. And again, this is an example of a CityGML dataset now visualized in 2D and in 3D directly from FME, so without using QGIS at all. So to conclude, these are my last 2-3 slides. Yeah, I just wanted to make you aware that you can use the 3D Staging Tools plugin in order to, well, have access and consume CityGML or CityJSON data stored in the 3D CityDB in a quite easy way. It's open source, so you can use it. And actually, we're very happy about constructive feedback. What is important is that, of course, if you are just on the graphical user interface side, you can use QGIS, but you can also interact directly with it by means of FME, which I showed you. But for example, we can also access it by Python or SQL Alchemy or whatever. Just to give you an idea, this is how it looked like. So when you want, for example, to query all building roofs constructed since 2015. This is the plate for the CityDB. You need to do a lot of joins. It's possible, and if you are an expert in SQL, this is not really complex, but it might be beyond the scope of some users. This is how it looks like when you write an SQL statement directly using the QGIS package. So it's 50% less, you can say, but you can perform, again, the same operation directly from QGIS, just using the existing tools together with our plugin. Everything is online. This is also the GitHub repository, and you can also already download it. It's available on the QGIS repository homepage. So this is my very last slide for today. I see I am 4 minutes late, but I hope this is not too much bad. I thank you for your attention, first of all, and I can start sharing, I think, and go back to normal.
Yeah, thanks. Thanks, Giorgio. I think that there are a couple of questions. Before leaving the floor to you, to some questions, I saw one from Alessandro in the chat. Let me just highlight and remind the reasons why we decided to introduce CityGML within a project that is focused on indoor air quality. Because well, but mainly three main reasons. The first one is that, as you clearly showed, there is a lot of stuff already available out there when talking about environmental data, and in particular in terms of data models and software for dealing with data related to buildings. In the EDIAQI project, we have to consider also some basic and static properties of buildings and building parts and indoor environment. And there isn't, in my opinion, any need to reinvent the wheel. So we need to consider the possibility and the opportunity to have our own pilot buildings in a EDIAQI project modeled as you showcased. And I pasted a screen that I took from your presentation. So simply representations of pilot buildings of the EDIAQI project could be done quite easily with a few basic properties and presented also in a graphical and geographical way like this screen. Of course, to do that, we need tables and we need the data to be properly stored and properly managed. And I would like also to stress a second reason why CityGML for EDIAQI. The second reason is that somehow in EDIAQI we have pilot buildings in different cities that can be seen as a reference buildings. So that means that there are other buildings already existing in Zagreb, in Vilnius, in Tallinn, in Ferrara, in Sevilla. So similar to the ones considered in EDIAQI pilot areas, having similar properties. And the third and final reason is that we definitely need to model our own pilot buildings in EDIAQI in a proper and standard way, only for allowing a correct sharing of this data. So we need to think of a standard data model for enabling and facilitating the sharing of data. That means the sharing in terms of interoperable data models, interoperable formats, interoperable semantics, and also interoperable means of viewing and downloading this data. So the idea behind this fourth webinar is to stimulate all of us, so all EDIAQI partners, in thinking of how to exploit maybe a little part of CityGML standard also for the purposes of our project. And the objective is quite clear: is we don't need we don't need to reinvent the wheel. I would like to leave the floor to Alessandro and also to Alessandro Battaglia from Lab Service Analytica that that brought a question in the chat that is the question of the questions. So how to deal with CityGML or other standards that are coming from the geomatic world in a project that is focused on indoor air quality. Alessandro, are you there?
Yeah. I'm here. I don't know if you can see me also, but I activated the webcam. Yeah, I found what Giorgio said very interesting and important for our project scope and our outputs. Yeah, my question is easy, but is an important question mark. So how can we handle with the indoor air quality data? So how can we use CityGML and all the tools you showed you in your presentation for our project scope?
Okay. Well, of course, I can only give suggestions, and then it will be you deciding upon it. I see here two possibilities depending on which, for example, version of CityGML you're going to use, and each one has pros and cons. As I mentioned before, CityGML 2 has at the moment more tools available. CityGML 3 is, however, more powerful from the modeling capabilities in terms of conceptual model. And it has already, let's say, it comes with the embedded possibility to model to connect to sensors. So I will try to split the answer in two ways. According to CityGML 2, there are itself two ways of dealing with that. So if you consider CityGML pure, so just the city model, the data model, I would probably go for defining some objects, and you can do it by means of generic city objects, so you don't need to extend the data model. You have this possibility of creating generics, so you could create a generic city object which represents your subdivision of the building. Of course, you have rules. I didn't mention it because it would go too much into the details of the data model, but you can check, and actually you have Giorgio, who is quite well expert on it. There are indeed already classes that go down mostly at the bin level, so you can model indoors. You can model rooms, you can model doors, you can model windows as already included in the database, in the schema. If you come up with some objects that are not already identified by the data model, you could instantiate them as generic city objects. And that could be, for example, a sensor that you then place somewhere and you connect it, or you provide it with the sufficient metadata to connect to the sensor. Okay, so this would be CityGML2 without the need to define anything. You just use the city model, the data model as it is. An alternative, if you and this would be probably the easiest way, which I would go. In the work we did for the energy application domain extension, we also defined new classes. One of these is the building usage, okay, which is a quite generic subdivision of the building, and it can be only semantic or it can be even with geometries. But I assume that most of the times you will not really have geometries about the indoor places, or you may have to digitize that, whatever. So having a geometry is an optional item. So you could use this building usage class, and inside a building you can have as many as you want. Of course, there is a geometrical limit because you fill up the building, but if you don't have geometries, you can define as many as you want, and then associate again probably the sensors to these building units, or building usage zones. And for this, again, this is an extension. It has already been published. It's called NGD. You are using it just probably for a very tiny part, which is this usage part. But again, there is also a database extension available. So tools are already there that can be used, and probably this could be a second option. If you go into CityGML3, of course, you have way more modeling capabilities because you first have, well, the concept is the same. You can go down to the room, but you can also define your, thanks to this space concept, you can define whatever logical clustering within a building. You can imagine so that the usage zone from the NGD can be easily mapped conceptually now and can be created inside CityGML3. And on top of that, you already have this dynamizer module, which among the rest enables you to model one object, to instantiate a class to describe an object, which could be a sensor, by natively defining the metadata, connection parameters, type, description, which you can retrieve to connect to the object itself. What is the price to pay? It is possible to pass CityGML3 data in which is XML based. In CityJSON, it is the same. The current version of CityJSON 2 supports a subset of CityGML3, and this could be possible. When it comes to the database, it's going to be released soon, but it's not currently available, so that there is no database which is still published as open source for the CityGML3. It should be published before the end of the year. That's the idea. But again, there will be no, for example, QGIS plugin, because this is, for example, one of the master theses that we are going to start with next month, how QGIS plugin can be adapted for the upcoming version of the 3D CDB, which will have full 3D CityGML3 capabilities. So it's a long answer because there are different paths, and yeah, this is basically what you have to consider together, probably with Giorgio or the other colleagues. And I just have a nice comment. I have the feeling that the room you are has a familiar feeling. Are you in FPK? Okay, that's why it comes up a little bit familiar. Okay, yes, Pier Giorgio?
Yeah, there is another question from Lina. Lina is working in Tropos, a research center in Germany, asking if there are big enough data sets available for indoor projects that have used CityGML. I guess the answer is no.
Not
for the
big
time
data
being.
sets. For the
Yeah.
time being, not. There are test data sets. Yeah.
Yeah, there are. There are large data sets in some countries, like the ones that you mentioned in the Netherlands, in Poland, emerging.
Germany.
Yeah, in Germany as well. Yeah, of course, in Germany as well, with 3D data about buildings that are already available or somehow available. So data are already existing for representing the 3D geometries of buildings as a whole. In the EDIAQI, of course, we are referring only to few buildings, few pilot buildings in different areas. And after the coffee break, I would like to start with the EDIAQI partners in talking and presenting a very pragmatical and practical proposal. Here in the screen that I'm sharing, we have a draft version of an Excel file that Honey from Tropos started to share with some of us yesterday, summarizing all the parameters, all the, let's say, data sets that we need to consider in our project. And when talking about building, she started to draft and list some very, very basic properties. So after the coffee break, I would propose to have a 15-minute coffee break. I see Honey, that Honey, you raised your hand. So
yeah, we can talk about it after if there's a
yeah.
time for it, then we do it after.
Yeah. Because after having thanked Giorgio, of course, Giorgio, you are welcome to stay with us after the coffee break. But after the coffee break, the idea is to focus on a practical and simple proposal on how to start thinking of modeling data about buildings in a EDIAQI project, and also how to collect and share the basic data, some of them already somehow listed here. And I will showcase a practical, very, very simple proposal. So I will leave this discussion after the coffee break. Again, Giorgio, thanks a lot for this very stimulating introduction to the CityGML. Of course, CityGML is, we know, maybe too big for us, but it was and it is important to you to give us this big stimulus in understanding that there is a lot of stuff out there in terms of data models and in terms of also of software for dealing data about buildings. It's up to you to stay with us after the coffee break or not. If not,
I have more or less half an hour, so up to 11:30. I could jump, of course, if it
okay.
can be
So
meaningful. Then I have another meeting, but I think half an hour, 40 minutes will be fine if you believe that it makes sense.
Okay, so I'm stopping the registration for this initial part, and I will leave the